Okay, good day, students. Raise this up. So, celebrating the holidays. Today is for the lesson of December 17th, and it also will be the lesson for December 20th. So, today was a shortened class day because we had a 2-hour delay. So, I'm not sure what's going to happen on Monday, but at least I'll be able to put this onto the site. So, for today's class, I need a calculator, pen, and pencil. We're going to go over the homework assignment and we're going to go over some extra practice for substitution. So that's what the white paper is. So on here, we have the homework for substitution. In most classes, I already went over problem number 2 and problem number 4, but I'll go over it again. So for number 1, we have x minus y equals 0, 5x minus 3y equals 10. And the first thing that we have to do, we need to solve one of these equations for either x or y. In this situation, I would go for the first equation for x. And the reason why, there's nothing in front of that x other than a 1 that's assumed to be there. So it will be easy for me to solve for y. All I have to do is one step. In this case, I'll just have to add y on both sides. Actually, I'm solving for x. So when I add y on both sides, I have x equals 0 plus y, but 0 is a placeholder, so I just have x equals y. So with that, I'm going to take my y, and I'm going to substitute it in for the x in the other equation. So once I do that, I'm going to have 5 parenthesis minus 3y equals 10. And then inside that parenthesis, I'm going to put my y because I'm substituting the y for the x. So from here, I'm just solving. So 5 times y gives me 5y. 5y minus 3y will give me 2y equals 10. So 2y equals 10. I have to divide both sides by 2. So now y equals 5. So as I look, I found y, now I need to find x. So when I find x, I'm going to take that 5 and substitute it for y in the other equation. But if x is going to equal y is, and y is equal to 5, that means x is also equal to 5. So I found my x, I found my y. So my point of intersection for those two equations is 5, 5. So repeating number 2, both equations are equal to x. Since both equations are equal to x, that means I can set those equations equal to each other. So in this case, I'm going to solve. So it's almost like this 4y minus 5 substituted in for that x. So I'm going to solve this for y. Easiest way would be for me to subtract 4y on both sides. So now I have a negative 5 equals negative 1y. And I don't want to know what a negative 1y is. I want to know what y is. So in order for me to do that, I need to divide a negative 1 on both sides, which will give me an answer of 5 equals y. So this is what y equals. I need to figure out what x equals. I can use either one of those equations to figure out what x equals. And it wouldn't matter because either one is going to give me the same answer. So if I plugged it into the first equation, I have 4 times 5, which gives me 20. And 20 minus 5, that will give me 15. But if I plugged it into the second equation, instead of that y, I will put a 5. That also gives me an answer of 15. So hopefully that proves it doesn't matter which equation I use, just as long as I plug it in for the right variable. So my point of intersection for problem number 2 will be 15, 5. So number 3. Number 3, I want to solve for either x or for y. So in this situation, I won't mind solving this first equation, and it could be the second equation. But I know for sure, as soon as you saw that fraction, you probably said to yourself, I'm not going to do that. So I want to solve this first equation, I guess, for x. And remember, it doesn't matter which one you solve for, as long as you plug it into the right variable. So if I want to solve this for x, that means I need to add y to both sides. And I got 4x equals 2 plus y, because I can't combine those two. I'm adding. From here, I'm going to divide everything by 4. So in this case, I have x equals 0.5, because I know how much you love fractions, plus 0.25y, because there's a 1 that's assumed to be in front of that y. So 1/4 y. So this is what I'm going to plug in for x in the second equation. So when I rewrite the second equation, I have 2 parentheses minus 1/2 y equals 1. And inside that parenthesis, I'm going to write 0.5 plus 0.25y. So now, we can't do anything inside the parentheses. We don't have any exponents. So what the first thing I should be thinking of is distributing the 2 to that 0.5 plus 0.25y. So 2 times 0.5 will give me a 1, plus 2 times 0.25, that will give me a 5. Minus my 1/2 y equals 1. So when I do that, I got my like terms on the same side of the equal sign. Oh, sorry, 0.5. So now I have 0.5y minus 1/2 y. And we all know that 1/2 is the same as saying 0.5. So if I have one that's positive and one that's negative, they automatically equal to 0, which leaves me 1 equals 1. So since 1 can equal 1, that's telling me that I have infinitely many solutions. So that means any point on those two lines, they're going to be intersecting. Translation, if I put those two equations, these two original equations, if I put them in slope-intercept form, I will get this same exact line. Okay? So if I have a number that's equal to itself, whoa, that was funky. If I have a number that's equal to itself, that means I'm going to have infinitely many solutions. So now I'm just going to shift this over a little bit. Shift that. Give this a quick erase. So I get a little room for number 4. Alright, so looking at number 4. So right away, I want to solve one of these equations for either x or y. So let's say I want to solve this first equation for x. So if I do that, I have to, sorry, or let's solve it for y, why not? I have to subtract x on both sides. Then I have y equals 8 minus x. And I'm going to take this information and I'm going to substitute it in for y in the other equation. So when I write it, I have x plus, that's going to be a parenthesis in there, equals negative 1. And I'm plugging in 8 minus x inside. So since there's nothing in front of that parenthesis other than the plus sign, I don't have to distribute. I can go ahead and combine like terms. So when I combine like terms, I have 1x here, and I have a minus x here, which automatically gives me 0. Not x, 0. So if it gives me 0, what's left over? My 8 equals a negative 1. Now, ask yourself, can 8 equal a negative 1? It is not possible. So that means I have a no solution. And when I have no solution, that's telling me I have parallel lines. Okay? So if you refer back to your notes that we take about, I want to say 3 classes, maybe 4 classes ago, when we have parallel lines, that means our slope are exactly the same. When you have the same slope, you're going to have no solution, which as a result will give you parallel lines. So we have no solution. Number 5. So we're going to solve. The easiest one that I see, I want to solve this first equation for x. So if I solve it for x, I'm subtracting 6y on both sides. So now I have x equals 7 minus 6y. This is going to go and be substituted in for x in the second equation. So when I write out the second equation, I have a negative parenthesis plus 4y equals negative 2. And inside that parenthesis, I'm going to write 7 minus 6y. And you're probably saying, well, why didn't you just put 7 minus 6y instead of a parenthesis in front of it and a negative sign in front of it? Because remember, you're substituting only for the x, not for negative x, for positive x. So now we're going to have to distribute. And when you distribute a negative, you're just simply changing the signs. So instead of a positive 7, you have a negative 7. Instead of a positive 6y, negative 6y, you're going to have a positive 6y. And then you're bringing everything else down. So after you do that, you want to get your like terms together. So in my case, my like terms are right here. That's 6y and that 4y, which currently gives me a 10y. And since it's positive, there's a plus sign there. Bring down my negative 7 and bring down my equals negative 2. So since I'm solving for y, I need to add 7 on both sides. Then I have my 10y equals 5. And I have divide 10 on both sides. And y is not equal to 2. I know you're thinking that. It's 5 divided by 10, not 10 divided by 5. 5 divided by 10, that will give you an answer of 1/2 or 0.5. Okay? So we're saying $5 is half of $10. Okay? So that's what y is. Now we need to know what x is. So we're taking our formula for x and we're plugging it in. We're plugging that 0.5 in for our y. So 6 times 0.5 will give you a 3. Everything else we're going to bring down. So x equals 7 minus 3, which gives you 4. So my ordered pair for this case will be 4 comma 1 half, or 4 comma point 0.5. Remember, it's your x value, then your y when you're making your ordered pairs. All right? And last but not least, if you want to do some of these by yourself, remember, hit pause. Okay? Hit pause and then check your answers with mine. That might see if you really get it or if you don't get it. Okay? So let's see. So now, I'm looking at the first equation because this x is by itself. So that means I'm solving for that x. In order for me to solve for that x, that means I have to subtract 2y on both sides. So my equation turns into x equals 1 minus 2y. If you said negative 2y plus 1, that's the same thing. So now we're going to take that and we're going to substitute it for x in the other one. So I have 5 parentheses minus 4y equals negative 23. And I'm going to substitute that 1 minus 2y in for it. So next step, I should be distributing. So 5 times 1 gives me 5, minus 5 times 2y gives me 10y. And now I'm bringing down the negative 4y equals negative 23. So as you can see right here, I have like terms. So let's combine. So this is all the other class. So I'll combine them. I should get a negative 14y. Bring down my 5. Bring down my equals negative 23. So since I'm solving for y, that means I'm subtracting 5x. Subtracting 5 on both sides. Then I get a negative 14y equals a negative 28. Divide both sides by negative 14. So that's telling me y equals 2. Positive 2. So if that's what y equals, what does x equal? So x equals 1 minus 2y. So instead of that y, I'm putting in a 2. So, please excuse my dear Aunt Sally states that I need to multiply first, since I don't have anything in the parentheses. I don't have any exponents. So I have 2 times 2, which gives me 4. 1 minus 4 gives me a negative 3. So now, what is my ordered pair? Negative 3, comma 2. Okay? So as you can see, I know it looks a hot mess right now. But remember, walk yourselves through it step by step. Okay? What we did in class, we did some extra practice. Unfortunately, on my first period class, today was a B day. For my first period class today, December 17th, a lot of the seniors and juniors whose last names begin with A through L, they had an assembly. So my normal class of 30 or 28, I basically had 8 students in it. So obviously we're going to be going over that extra practice once we get back from after break. Okay? So my suggestion, the copy of the extra practice is on the website under classwork, okay, for second semester. Okay? Once you click on that, I actually have it listed as December 17th, December 20th classwork. print that out and try to give it, try a little practice with it. See if you understand the flow of it. See if you understand, okay, if I'm solving for this, I'm going to solve for that. And once we get all that situated, I'll put it on the website, and then we're going to talk about it once we get back from the break. For those that don't know, on the 21st and the 22nd, I will not be here. I'm currently going to be graduating from UMBC. So I have a graduation, and after that, I have to go away. Okay? So, but I will definitely be back. Don't cry. January 3rd. Okay? Once we get back from break, we're going to do a little bit more with systems of equations and also going to be working on the midterm. So my sub and Ms. Calvinella will have the work for the kids to do on, sorry, young adults, not kids, to do on the 21st and the 22nd. You guys are going to work a little bit more on your projects and also going to start working on your midterm packets. Okay, so today on the 21st and the 22nd of December will be the first time that the students will be working on their packets. Okay, so hopefully this will help out, but we will definitely go over it again once we get back from the new year. All right, so if I don't talk to you soon, enjoy your holiday, enjoy your break, and please be safe.